Now we're going to interpret derivatives in context. So a lot of times on the AP exam, they will want you to find a derivative, which we will learn how to do later on, but they will also ask you to interpret it in the context. And you have to be able to understand what they're talking about and why they're talking about it and what it represents and all that stuff. So if we look at this example, the position of a particle is given by the equation of motion S equals F of t, where t is measured in seconds and S in meters. What does F prime of 10 equals -3 mean in this context? So there's kind of like an outline, which I have as this hint on the bottom. So you can kind of follow this particular outline for any type of question where you have to interpret it in the context for the derivative. But when you use this, it just kind of makes you sound like a robot, which is fine. So if you want to just, keep using the same format to answer the questions, that is totally fine. If you want to write it more like how you would talk, I guess, we'll show you both ways. And it's just kind of like the same interpretation, but just wording it a little bit differently. So for this hint, whenever interpreting derivatives in context, you can use this basic format, even though it may sound like a robot. You can change the wording depending on the context if you would like. So the basic format is the rate of change of blank, which is the y value in context, at time blank, which is the x value with units, is blank, the y value with the y units divided by the x units. So first thing that you always just want to make sure you remember is that derivative is the rate of change. So whenever a question is asking you for the rate or about the rate, you're going to use derivatives. And again, we don't necessarily know how to use them yet, but we will. If the question's asking you about derivatives, that means you're going to use rate. So like rate and derivatives are like the same thing. They go hand in hand. So the rate of change is like super important to have involved in your interpretation. So if we're trying to interpret this, the first thing we have to find is the y value in context. So what does y stand for in terms of this problem? So the y value is the position, right? The position is S equals F of t, right? So that's like our y value. And in context, it stands for the position. So the rate of change of position at time, the x value with units. So the x value, this is what we're interpreting here. So the x value is the 10. So it's 10. And then the units for the x value is seconds. And then the next blank is the y value. So here the y value is -3. And then it has the units that are the y units. So y is the position. So the position has units of meters. And then the x units is time, and that's seconds. Okay, so you can use this format and you could say that the rate of change of position at time 10 seconds is -3 meters per second, which is totally a fine way to interpret this. If you were having a conversation with somebody about this problem and like talking about it in the context of how you would, I guess, normally speak, I would say something like at t equals 10 seconds, because you want to make sure you still have all this information in there, but if you don't want to make it sound so like, I don't know, rehearsed, I guess, you can change it up. I'm going to say the change in position is -3 meters per second. But then again, when you think about -3, like you can say, oh, it's -3, but you want to kind of interpret it in like, what does it mean in the real world? So in this case, it means that the velocity is -3, or that the particle, so I'm going to say meaning, it's supposed to be a comma. That does not look like a comma. Let me fix that. Oops, whoa. Meters per second, comma, meaning that the particle is moving in the negative direction. Okay, so negatives are meaning negative direction, or they're meaning that something is decreasing. So we want to take into account the sign. Okay, let's look at one more. So the temperature of water in a tub at time t is modeled by a strictly increasing, twice differentiable function w, where w of t is measured in degrees Fahrenheit and t is measured in minutes. What does w prime of 12 equals 1.017 mean in this context? Use proper units. So again, we can write this using our form. So let's, I guess, do that first so you can follow that. So we would say the rate of change, right, because we're dealing with the derivative, so the rate of change of, and we have to figure out what the y is in the context of the problem. So in the intro here, they kind of give you a lot of information, maybe things you don't know, like twice differentiable, like what that means. We're going to cover all this stuff later. So right now, there's just some background information. The main thing is that the y value here is the w of t, which is the temperature of the water. So the rate of change of the water temperature, I'm just going to put water temp, at time 12 minutes, right, because that's our x value, is, and our y value is this 1.017. And the units, the y units, so y is the temperature, so the units for that is degrees Fahrenheit divided by our x units, which is our time, so in this case it's minutes. Okay, so we could say the rate of change of the water temp at time 12 minutes is 1.017 degrees Fahrenheit per minute. That is perfectly all right to say. I'm just going to write it another way that I guess is more conversational. So I would say something like the water temperature. I'll say again temp. The water temp, because it's positive, right, it's increasing. If this y value is negative, the temperature would be decreasing. So it's, again, pay attention to the sign that you have. So the water temp is increasing at a rate of 1.017 degrees Fahrenheit per minute at time t equals 12 minutes. So notice that I wrote it a little bit differently. Maybe it flows a little bit better. I didn't use the words rate of change, but I did use the word rate. So rate is the main thing. Derivative and rate are the same thing. Rate is just rate of change. So if you're more comfortable following this format, go for it. If you want to kind of start interpreting it a little bit differently, so it's, more like how you would speak maybe, that's fine, but you want to make sure you have the keywords in there. So you want to make sure that you have what the y value stands for. You want to make sure you have the rate in there. You want to have the x value. You want to have the y value, the right units. And then I always pay attention to the sign. So if it's positive, it's increasing or moving in the positive direction or whatever. If it's negative, it's decreasing or moving in the negative direction, depending on whatever the problem is.